Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 7 from the Mechanics M1 October 2021 session. And this question here is about connected particles, inclined planes, friction, and so on. So it says one end of a light inextensible string is attached to a particle A of mass 2m. The other end of the string is attached to a particle B of mass 3m. The string passes over a small, smooth, light pulley P, which is fixed at the top of a rough inclined plane. The plane is inclined to the horizontal angle alpha, where the tangent of alpha equals 3/4. So the tangent of alpha equals 3/4. All right. So what that means here, we're going to have to resolve forces horizontally or parallel and perpendicular to the plane in this case. So we're going to have to know the sine and the cosine of the angle here. So better than actually finding the value of the angle, find the value of the cosine and the sine of the angle. That gives you more exact answers. So what I'm going to do is I'm going to draw a little triangle, and I'm going to call this angle alpha. I'm going to make sure it's a right angle triangle. So the tangent of alpha, if it's 3/4, that's opposite over adjacent. This is a right angle triangle, so Pythagoras' theorem does apply. This is the hypotenuse. So it's a 3, 4, 5 triangle. If I was to square this side, get 9, square that side, get 16, add to them together, get 25. Square root of 25 is 5. So this is a 3, 4, 5 triangle. So now I can write down the exact value of sine alpha, which is opposite over hypotenuse, 3/5, and the exact value of cosine alpha, which is adjacent over hypotenuse, which is 4/5. Now that's much better than using like finding this angle and then having it as a decimal and then writing it down, cosine and cosine alpha in terms of decimals or rounded values. It's much better to use this. That's why they give the angles in this format. So that's just preparing us for later on. Now let's read the question. It says a particle A is held at rest on the plane with the string taut and B hanging freely below P as shown in the figure. The section of the string AP is parallel to the line of greatest slope of the plane. All that means is if there's a slope going up, that this pulley's up there, the string's kind of like parallel to the line of greatest slope of the plane. So it's not like going across here. It's like straight down. Okay, that's what it kind of means. I don't know if you can picture what I'm trying to draw there, but anyway, it's not such an important point for you to. It doesn't really affect the question that much. In terms of what you have to write down, the coefficient of friction between A and P and the plane is 1/2. So that's the value of mu, which is the coefficient of friction, which is 1/2, and we know that F max is equal to mu r, which we'll talk about later. Okay, it says for the motion before A reaches the pulley, so it says particle A is released and begins to move up the plane. So it goes up the plane. Alright, for the motion before A reaches the pulley, write down an equation of motion for A and write down an equation of motion for B. Okay, so here they just want you to write down the equation of motion. I don't think they want you to put any values and stuff in. So let's get on with that. Let me just take this diagram. Okay, so here's the diagram. So we have the forces. Let's draw the forces acting on this object. So we have here the weight of this acting straight down and the weight of this acting straight down. The weight of this is mass times g, so this is 2 mg newtons and this is 3 mg newtons. We have the tension in the string pulling up, tension in the string over there. We also have in this case we have the frictional force opposing the motion. Now this thing is moving in this direction and this one in this direction, of course. So the force of friction is going to oppose the motion. So the frictional force is going to act down, and it's going to be the maximum value of friction because it's moving. Okay, as it's in motion, the friction has reached its limiting value. So this is F max, you could say. And the other forces acting on this, which we don't really have to worry about in this particular part of the question, is the reaction force acting when two objects are in contact with each other, which is perpendicular to the plane, and of course it will be like opposing the component this way. So we have here two things. We have here object A, which is moving in this direction, and object B, which is moving in this direction. So I'm going to resolve the forces in both directions. For B, it's pretty simple. It's going downwards. I'm going to take down as positive. Okay, so I'll say that this is going to be the force acting downwards, 3 mg, minus the force acting upwards, T. The resultant force is equal to ma. The mass is 3m, so it's 3m times a. That's using the equation of motion. Basically means F equals ma. The resultant force is mass times acceleration. So we applied that for B. The resultant force is 3 mg minus T, and that's equal to 3 ma, the mass times acceleration. Okay, for A, we have to resolve the forces acting parallel to the plane. So I'm going to take this force here, which is the force of the weight, okay, on A, and I'm going to resolve it parallel to the plane. Okay, parallel to the plane like this, and also perpendicular to the plane. Alright, now what we know is that this angle here is the same as angle alpha over there, by similarity, which I've explained in a few videos before, okay, when we've dealt with inclined planes. If you can look at, you can go back to some of them and see where I've explained why this angle is the same as the angle. It's to do with similar triangles. Okay, so this is the angle alpha. Now, if I resolve this force parallel to the plane, basically what I'm finding is I'm finding like the opposite to alpha. So you can use sine, or you can say if the line of the force you're resolving moves away from the angle given, like here the angle is on this side, I have to resolve it away from the angle. I have to use sine. So this is going to be 2 mg times sine of the angle. And if I have to resolve the force going into the angle given, or you can think of it as like this would be the adjacent side, if you know, thinking about this as a triangle. This, what I'm resolving is the adjacent side, so I'm going to use cosine. So this is 2 mg times cosine alpha. What I'm concerned with is the equation of motion. A is moving in this plane, it's going up the plane, so we can say that the resultant force is T minus the frictional force, which has reached its maximum value, and minus the component of the weight, which is 2 mg sine alpha, is equal to the mass times acceleration, which is 2 ma. Okay, so that's basically, let me make that a bit neater. Okay, so that's basically the forces of motion. So we're going to have, I'm resolving A, taking this as positive going up the plane. So as I said, T is going up, the frictional force acting down, the component of the weight acting down the plane is 2 mg sine alpha, and that's equal to the mass, which is 2m times acceleration A. So this is what they're looking for in part A. They're not looking for you to put any values in here or anything. That's fine. That's perfectly good for part A. And we can move on now to part B. Okay, so we're going to use what we did in part A for part B. Part B, it says find in terms of G the acceleration of A. So now what I'm going to do is I'm going to complete the equations that I need by finding or resolving the forces on the plane perpendicular to the plane. So here I'm going to have, if I take that as positive, I'm going to have R is balanced out by the component of the weight acting perpendicular to the plane, which is 2 mg cosine alpha. Okay, so remember we have from the first page that mu is a half. We said sine of alpha is equal to, that's 3/4, so 3/5, and the cosine of alpha was equal to 4/5. Those are the things that we deduced from the information that they gave us in the part of the question earlier. So we got to find in terms of G the acceleration of A. So we got to find what A is in terms of G. So let's start filling in some of these bits of information. First of all, we know F max is equal to mu times R. Alright, and I know mu is equal to a half, as we told before, and I know that R is equal to 2 mg cosine alpha. I know that R is equal to 2 mg cosine of alpha. And I know that cosine alpha is equal to 4 over 5. Okay, that's all stuff we deduced earlier. So F max is going to be mu, which is a half, times R, which is 2 mg cosine alpha, which is equal to, let me just write it here. Just to make it neater. This is going to be mu times 2 mg cosine alpha. So we have all this information now. We have mu is a half times 2 times mg times cosine alpha, which is 4/5. Okay, so we can say that's F max. So therefore F max is equal to, they cancel out, 4 mg over 5. That's F max. Okay, so we found what F max is. All right, so I can use this equation now, and I also can find out what this is. So now if I take this first equation that I found, which was, if we resolved horizontally, we got, or parallel to the plane, we got T minus Fm minus 2 mg sine alpha is equal to 2ma. That's one of the equations that we deduced. So we know what Fm is. Fm now is 4 over 5 mg, and here you got minus 2 times mg times sine alpha, which is 3/5. Okay, and that's equal to 2ma. So we can, from this half of the equation, T, this is going to be minus 6 over 5 mg. That's minus 4 over 5 mg. That's going to be minus 10 over 5 mg. Okay, that's going to be minus 6 over 5 mg, minus 4 over 5 mg. That's minus 10 over 5 mg equals 2ma. So we can say T minus 2 mg is equal to 2ma. All right, so that's one equation now I have, which I can use. And now I can see that there's another equation that I can use, which is this equation here, okay, which is for B, which is 3 mg minus T equals 3ma. Now if I take these two equations and I add them together, if I do equation 1 plus equation 2, what I'll be left with is the acceleration. Well, an expression with acceleration. The T will cancel out, because I'll have T plus minus T, which is 0, minus 2 mg plus 3 mg, which is going to be 1 mg, and this will be 5 ma. So the m's cancel out, so I'm left with A is equal to 1 over 5 g. So that's the acceleration in terms of g. So that's part B done. Okay, now for part C, this question is asking us to find the magnitude of the force exerted on the pulley by the string. Okay, so now the pulley here has forces acting on it, which are from the string, okay, being pulled down basically by these masses. So there's a tension acting in this direction and a tension acting in this direction, and the tension in the string is the same on either side of the pulley. The pulley is a smooth pulley, there's no friction in it, so therefore that tension is the same. So the magnitude of the tension acting in this direction and that direction, they're both the same. So we have to find the magnitude of the force exerted on the pulley, which will be the resultant of these two tensions. So we need to find the resultant of these two tensions. So let's find first what the value of T is, and then we can find the resultant of these two tensions and resolve them such that we can find the resultant tension. So what we can do here to find the tension, the value of T, in terms of mg here, by the way, is we can use one of these two equations that we have, and we can make T the subject. I think the first one looks a bit friendlier. So from the first equation, we got T equals 2 times ma plus 2 times mg. And A is 1/5 g, so we can replace the A with 1/5 g. So 2m times 1/5 g plus 2 mg. Well, that gives us 2/5 mg plus 2 mg, which you can then therefore say is, well, that's, you can say this is 2/5 plus 10 over 2. 10 over 2 is 2, right? Sorry, 10 over 5, not 10 over 2. 10 over 5 plus 2 over 5 is 12 over 5. So that's 12 over 5 mg. That's the tension. But we have to find the resultant of those tensions. So let's keep them in terms of tension now, in terms of T until the end, and I'll just substitute that value in. Now I need to find the resultant of those two tensions. So we can think of this whole thing here as a triangle. Okay, just to think about these angles. And what I can do here is I can think of finding the resultant of these two forces, resultant of tension going this way and that way. So let me start with this one. Just imagine that we draw a vector diagram of forces. So there's these two forces acting on the pulley P. Okay, now for question number 7C. It says find the magnitude of the force exerted on the pulley by the string. So we found the acceleration of the system, and now we need to find the magnitude of the force exerted on the pulley by the string. So in the string there is a tension, as we mentioned before. The tension, if we're considering the masses, the tension's acting, pulling the masses upwards, kind of thing, right? So this tension here, this tension is countering the weight. But there's also, if we consider the pulley, if we're considering the pulley, the tension's acting this way and also that way. Okay, pulling on the pulley, basically pulling the pulley down. So there's a force acting on the pulley, which is caused by these two tensions. So the first thing we need to do is to find out what the value of the tension is. That's the first thing. And then we can work out the resultant of these two tensions on the pulley, and that would be the resultant force, or the force exerted on the pulley by the string. So what we need to do first is, as I said, find out the tension, and we can do that by substituting A equals 1/5 g into one of these two equations to find what T is in terms of mg. So if we replace, for example, this A into this equation 1, let's first rearrange it. So the tension is equal to 2 times MA plus 2 times mg. If we now replace the A with 1/5 of g, we have 2 times m times 1/5 of g plus 2 times m times g. That gives us 2 over 5 mg plus 2 mg, which means the tension is equal to, well, this is 2 over 5, and this is like 10 over 5 as a fraction. So that's 12 over 5 if you add them together. So 12 over 5 mg. That is the tension in the string. So if we consider now the forces acting on the pulley. Okay, the forces acting on the pulley is this tension this way and this tension that way. Okay, let's just get rid of this. We're not thinking about the masses, we're thinking about just the pulley itself. Okay, so if we draw a vector diagram of forces, so let's say we first draw the tension acting in this direction here. We draw that. Now, when you want to draw a vector diagram, you want to find the resultant of a certain number of vectors. Here, there's two vectors. You draw one of the vectors. So I'm drawing the vector that represents the tension in this direction. And then where that ends, you draw the other vector, which is this vertical one down here, which has the same magnitude. So it's going to be the same length of line, but it's going to act vertically downwards. Okay, you start drawing that. Now, where that one ends, okay, if you join that back to where you started the whole diagram from, that is going to be the resultant. So this is the resultant. This is the resultant force acting on the pulley. This is the, if I work out the magnitude of this line, the length of this line, that will be the answer to this question, saying the magnitude of the force exerted on the pulley by the string. So that's what I'm looking for. So you see we have a triangle here now, triangle of forces. What we can do is, let's make it look a bit more realistic. That should be slightly longer. It looks like an isosceles triangle a bit more. Those two lengths are the same. All right, so we could use a variety of methods. One of the methods we could use is the cosine rule. So if I know what this angle is here, let me call it theta for now, then I can use the cosine rule to find what this length is. Okay, so I know that for the cosine rule, a squared is equal to, b squared plus c squared minus 2bc times cosine a. where A is the side they're trying to find, and cosine A, A in the angle, capital A, is the angle opposite the side you're trying to find. So if I can work out what theta is, I know what T and T are, both of them. All right, they're the same, 12 over 5 mg. Then I can work out this resultant force in terms of mg. So now let's try and work out what theta is first. Now I know that the tan of alpha, if you look at this diagram here, is 3 over 4. That's what we know. And I know that this angle here is also alpha. If you think about this horizontal, that's horizontal. So if I draw a similar line up here, if I draw a similar line over here, this angle here would also be alpha. Okay, now, if I know that angle is alpha, or I'm just trying to find a quick way of finding out what this angle here is, then this angle would also be alpha here. If I draw a horizontal line through this angle, this will be alpha, and this part will be 90 degrees, because this is horizontal, this is vertical. So this angle here is, alpha, and theta, sorry, is 90 plus what alpha is. So if we can work out what alpha is by using inverse tan of 3/4, we can work out what that is. So we say inverse tan of 3 over 4. That gives us 36.869. Therefore, we can say our angle theta is 90 plus that. 869. Okay, so that gives us, add 90 to that, and that gives us 126.869. Okay, so that angle is, that's the angle alpha. What I'm going to do is, I'm going to store this as A. This angle is now stored as A in my calculator if I need to. Well, no, I will definitely need to use it again. So now I know the angle, I know these two sides, I can use the cosine rule. So I can say that, let me say that the resultant force is equal to the square root of t squared plus t squared minus 2 times t times cosine of theta. I'll leave it like that for now. Let's simplify this a bit more. So this is going to be 2 times t squared minus another 2 times t squared times the cosine of theta. Let's try to make it even more simpler. We can call this the square root of, let's take out 2t as common, 2t squared as common, 1 minus cosine theta, just to make it, I don't have to put t in there too many times. Okay, we can just make it a bit easier for ourselves. That's the same as that. So now let me put the values in. I know what t is. So it's going to be the square root of, now t, remember, was 12 mg, or 12 over 5 mg. What I'll do is I'll just put 2 times 12 over 5 squared times 1 minus cosine of the angle, which is 126.869. Okay, and in the end I'll put mg. I'll leave the mg outside. So let me just work out what that gives us. So I have the square root of 2 times 12 over 5 squared minus 1 in brackets, not minus, times, sorry, times, okay, times 1 minus the cosine of, now I'll just press, I think, recall A, that's the answer that we had stored. Close the next bracket, and that should give us our answer, which is 48 root 5 over 25 mg. 48 root 5 over 25 mg. So that is the answer for the resultant force. They did not ask us for the direction of this force. If they did ask us for the direction of this force, we would have to find what this angle is here, and then we could say it's a certain number of degrees from the vertical or for the horizontal, or we could give it as a bearing. Okay, they would ask, we could find the direction of the force if they asked us to. That wouldn't be too difficult. We could use the sine rule, for example, to find this angle. Okay, and then we could work out what the bearing is, or whatever the way they want us to describe it, we could describe it. Okay, so that's part C. Now for part D, it says state how you have used the information that P is a smooth pulley. Okay, now I think I already mentioned that when we said that these two tensions are equal to each other, okay, they are equal to each other because this is a smooth pulley, all right, and the tension on either side of the pulley in the string will be the same. So if you make a statement like that, the tension on either side of the pulley, something like this, is equal. The tension in the string, better right, in the string on either side of the pulley is equal, something like that. That's enough for the mark there, and that concludes this question, which is all about connected particles. If you would like to see other questions from this particular paper here, you can click on the link here for the playlist for that, in which you'll also find the PDF of the paper. You can also click on this playlist here to find questions related to M1 connected particles, and you can subscribe to my channel by clicking on this link here. Thank you very much for watching, and see you soon.